Hello everyone. Today let us discuss about lens maker's formula. It is one of the most important derivations and also most important derivation for the numericals, and it is frequently asked in the old question papers, and it is also used to solve most of the numericals in ray optics and optical instruments chapter. Let us start our discussion. Here I have shown this figure of a lens and I will discuss it in the next pages. Now here we have taken a lens. This formula, it is very useful for the manufacturers of the lenses. So this formula relates the focal length of a lens to the refractive index of the lens material and the radii of curvature of its two surfaces. This formula is called as lens maker's formula. This is called as lens maker's formula because it is used by manufacturers to design lenses of required focal length from a glass of given refractive index. What all the lenses we are wearing? That is, some of them are wearing convex lenses, some of them are wearing concave lenses. So they all are manufactured by these lens makers. So they use this formula to manufacture our spectacles. So let us consider a thin double convex lens of refractive index mu2. Here I have shown it. This is a thin convex lens with refractive index mu2. It is placed in a medium of refractive index mu1. Here if you see, mu1 is less than mu2. That is, refractive index of the glass is greater than the medium surrounding it. Let B and D be the poles. You can see here, let B and D be the poles. Okay, I'll remove the lines so that you can clearly see. Let B and D be the poles. And then let C1 and C2 be the centers of curvature. C1 and C2 be the centers of curvature. And R1 and R2, R1 that is from center of the lens to C1, that is R1, and R2 that is center of the lens to C2, R2 are the radii of curvature of the two lens surfaces ABC and ADC. ABC and ADC. ABC has a radius of curvature R1, ADC has a radius of curvature R2. Now, let us suppose a point object O, this is the point object O, is placed in the it is placed on the principal axis. You know, this is the principal axis. And the ray OM is incident on the first surface AB. The ray OM. So you can see from O, the ray is incident OM, that is the ray OM is incident on the first surface ABC. ABC. It is refracted along MN. It is refracted along MN. It is bending towards the normal. It bends towards the normal at this surface. So here we have drawn a normal, that is this one M. It passes through center of curvature C1. So MC1 is the normal at the point M. If the second surface ADC were absent, if the second surface ADC were absent, the ray MN would have met the principal axis at I1. Imagine this second surface ADC is not present, then this ray, after bending, it could have travelled straight like this. It would have met the principal axis at I1. So we can treat this I1 as the real image formed by the first surface ABC. We can imagine I1 as the first image formed by the surface ABC. So what we are talking is, first we are considering a lens with refractive index mu 2. Then O is the object. A ray from O goes straight to M. At M we have drawn a normal, that is MC1. Now the ray bends towards the normal. If the surface ADC were not there, this ray would have met the principal axis at I1. But afterwards we will discuss, because of ADC, how it is bent again. But first let us consider only the ABC surface. Then the ray has come up to M. It is bent towards the normal. If ADC, this surface is not present, it would have gone straight like that, and it would have formed an image I1 at this point. Now let us continue. Now for the refraction at the surface ABC, we can write the relation between the object distance u, image distance v1, because from here to here I1, that is from optical center to the image I1, the distance is v1, object distance is u, and the image distance is v1, and the radius of curvature is r1. So for this first surface ABC, O is the object, I1 is the image, object distance is u, image distance is v1, and radius of curvature is r1. So let us substitute in the previous equation which we have derived in our previous video, that is mu2 by mu2 divided by image distance minus mu1 divided by object distance is equal to mu2 minus mu1 by radius of curvature. Let it be equation number 1. Mu2 by V minus mu1 by U is equal to mu2 minus mu1 by R. So that is refractive index of the second medium divided by image distance minus refractive index of the first medium divided by object distance is equal to difference in the refractive indices mu2 minus mu1 divided by R1. So this is equation number 1. Let it be equation number 1. So now let us continue our discussion. This is very important. Let's go slowly. Now after that, actually the ray Mn, I'll take this one, the ray Mn, it suffers another refraction at the surface ADC. Because ADC is present, it didn't travel like this straight. Earlier I told you, if ADC was not there, it could have traveled straight like that. But because of ADC, it suffers another refraction at the surface ADC, bending away from the normal at the point N. What is the normal at N? NC2 is the normal at N. This is the normal. So the ray bends away from the normal, it comes along Ni. The emergent ray meets the principal axis at the point I. This is the final image of the object O formed by the lens. Now once again I repeat, the ray suffers a second refraction at the surface ADC. Where it touches the second surface ADC, there we have drawn one normal. That normal is NC2 passing through the center of curvature on this side, that is the left side. Now the ray bends away from the normal and it travels along Ni. Why away from the normal? Now it is traveling from denser medium to rarer medium. So it travels along Ni. So the final image is formed at I because of the object O and because of this lens which we kept here. So O is the object, I is the final image, and this is the lens. Now if we see that, if we take that into consideration, now what happens here? Now for this surface ADC, what is the object? For the surface ADC, I1 acts as the object, that is the virtual object placed in the medium of refractive index mu2. Now consider the surface ADC. For ADC, object is I1. The image formed by the first surface ABC becomes object for the second surface ADC. For the first surface ABC, O is the object, I1 is the image. For the second surface ADC, the image formed by the first surface, that is I1, it becomes the object for the surface ADC. Then the final image of I1 is formed at I. Final image is formed at I. So now if you consider this case, that is I1 acts as a virtual object placed in the medium of refractive index mu2. I1 acts as the virtual object placed in the medium of refractive index mu2, that is glass is made with mu2, and I is the real image formed in the medium of refractive index mu1. Now this is the first refractive index mu1, in that the image is formed. Therefore the relation between the object distance v1, now for this ADC surface object distance is v1, and the image distance is v. This is a distance from here to here, that is v. So let us consider that is the image distance, this is v, that is v. Okay, this is v. Then after that final image is formed at v. Then and the radius of curvature is r2. So radius of curvature for this side, this is r2, from here to C2, that is r2. Final image I is formed at a distance of v. Okay, then after that let us substitute these values in our previous equation. Let us substitute these values. Mu1 by v minus mu2 by v1 is equal to mu1 minus mu2 divided by r2. Mu1 minus mu2 divided by r2. Let it be equation number 2. This equation we got with respect to the second surface ADC. With respect to the second surface ADC. So V is the image formed. Now let us continue. I'll delete this so that you can see the clear notes. Yes. Now adding equations 1 and 2. What are equations 1 and 2? I'll take you back. This is equation number 1. Mu2 by V1 minus mu1 by U is equal to mu2 minus mu1 by R1. Now second equation, mu1 by V minus mu2 by V1 is equal to mu1 minus mu2 by R2. This is equation number 2. Now adding equations 1 and 2. Mu2 by V1 minus mu1 by U plus second equation mu1 by V minus mu2 by V1 is equal to mu2 minus mu1 by R1 plus mu1 minus mu2 by R2. Now in this case, if you see mu2 by V1 minus mu2 by V1 can be cancelled. Mu2 by V1 minus mu2 by V1 can be cancelled. So the remaining, if you take mu1 by V minus mu1 by U is equal to mu2 minus mu1 by R. This is, if you observe, mu1 minus mu2. So I am writing mu2 first. Therefore I am taking minus symbol in front. Therefore mu2 minus mu1 by R2. Actually this is a plus mu1 minus mu2 by R2. But I am taking mu2 minus mu1. Therefore, in the front I kept minus symbol, minus mu2 by mu1 divided by R2. Then in these two, mu1 is common, take it out, mu1, then 1 by v minus 1 by u is equal to, in these two things mu2 minus mu1 is common, take it out, then mu2 minus mu1, 1 by r1 minus 1 by r2. Then send this mu1 to the right side, 1 by v minus 1 by u, this mu1 will go and divide here, mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. Equation number 3. Equation number 3. Then let us continue. If the object is placed at infinity, then u is equal to infinity. Then the image will be formed at the focus. We all know the fundamentals. Suppose if the object is placed at infinity, then the image is formed at the focus. That means V is equal to F. V is equal to F. So in that case, let us take in the previous example, that is a previous formula. You can see here, in place of u, we will write infinity. In place of v, we will write f in this third equation. Then we will get 1 by f minus 1 by infinity is equal to mu2 minus mu1 by mu1 into 1 by r1 minus 1 by r2. 1 by f, 1 by infinity is 0. So 1 by f is equal to mu2 minus mu1 by mu1, 1 minus r1 minus 1 by r2. Equation number 4. Divide mu2 with mu1 and mu1 with mu1. Divide mu2 by mu1, mu1 by mu1. So mu2 by mu1, mu1 by mu1. Mu2 by mu1 is nothing but mu21. Mu1 by mu1 is 1. Therefore 1 by f is equal to mu2 1 minus 1, 1 by r1 minus 1 by r2. This is called as lens maker's formula. This is called as lens maker's formula. Very important, very important derivation. Okay, so now let's continue for thin lens formula. Then what we got right now is 1 by f is equal to mu2 1 minus 1, 1 by r1 minus 1 by r2. So this is the lens maker's formula. Now when the lens is placed in air, mu1 is equal to 1. For air, the refractive index is equal to 1. And let us take mu2 is equal to mu and substitute in this formula. So the lens maker's formula of equation 4. Equation 4 means this one. This is the one which I am taking. Okay, I will take with some other color. So this is blue color box. That is equation number 4. I will take this and I will go to the next page. That is 1 by f is equal to mu minus 1, 1 minus r1 minus 1 by r2. So 1 by f is equal to mu2 is equal to mu1 is equal to 1. So mu minus 1 divided by 1. So you will get here mu minus 1 divided by 1 means mu minus 1 into 1 by r1 minus 1 by r2. So comparing equations 3 and 4 we have. So let's go back. This is fourth equation and this is third equation. Third equation is 1 by v minus 1 by u is equal to mu2 minus mu1 by mu1, 1 by r1 minus 1 by r2. This is equation number 3. So what is equation number 4? 1 by f is equal to mu2 minus mu1 by mu1, 1 by r1 minus 1 by r2. See them again. You can see 1 by v minus 1 by u LHS. RHS mu2 minus mu1 by mu1, 1 by r1 minus 1 by r2. RHS here also the same thing. Mu2 minus mu1 by mu1, 1 by r1 minus 1 by r2. So both RHS right hand side are equal. So LHS here 1 by f and the previous equation it is 1 by v minus 1 by u. So when RHS of both equations are same, that is equations 3 and 4, we can equate LHS. LHS is 1 minus f LHS is equal to 1 by F in this fourth equation, then 1 by V minus 1 by U in the third equation. Equate both of them, you will get 1 by V minus 1 by U is equal to 1 by F. So this is called as thin lens formula. So this is the thin lens formula which gives the relationship between U, V and F of a lens. This is the thin lens formula which gives the relationship between U, V and F. Okay, so what we have done, we have derived the expression for lens maker's formula. We also have derived the expression for thin lens formula. Okay, thank you for watching this video. This video is really very important video. Make it use for the numericals. I will also upload the videos for the numericals in the days to come, and my next videos will be on the numericals, and also I will derive the expression for the refractive index of the material of the prism. That also I will derive in the next videos, and then we will revise all the important concept before exams. Thank you for watching this video. God bless you all. We will meet in the next video with another topic. Thank you once again.